Okay, so continuing on, we're going to now cover the topic of arrays. So arrays in computer science are, we've been in a situation where we have variables. Let's say we had a variable. We're not declaring the type here, so this is some kind of programming language where you don't have to declare the type of the variable. And we have team P is equal to the string Phillies. Team M is equal to Mets. Team Y is equal to Yankees. So we have three different variables, and they're all assigned to the names of three different baseball teams, local to our area. So suppose we wanted to print these teams' names out. Well, we would have to say print, give the variable of the P team, print the M team, and print the Y team. Print those out individually. So here's when we have three different variables, but they're kind of related. They all contain the name of a team, and the team is grouped in a container, the baseball league, right? So, so what is an array? Well, an array is a collection of variables that all have a common name to them. So for example, what we can do, it might make sense sometimes, for us to have an array of teams. And we might say we have three teams. We're going to have three teams. So we're going to now have three variables, and the three variables all have the name teams. Well, then how do we differentiate them from each other? We could do that typically, but not always. Python is now changing this a little bit. But typically, we could do that with an index, a number. So for example, we can make an array of teams. So it's a bunch of variables, all called teams, but each one gets a unique number. Kind of like, a family, and maybe every member of a family has the same last name, but they have a different first name, so you can differentiate them between each other. So the name of the array is kind of like the last name, and the number is like your first name, right? Kind of like that. Okay. So we could have teams 0 is the Phillies, and then a different variable, teams 1 is the Mets, and teams 2 is the Yankees. So now we didn't use three separate names like before. We use the same name, but we differentiate them with this index. And then, if you remember when we talked about loops earlier in the semester, we can now say for I starting at 0, as long as I is less than or equal to 2, iterate through the loop, and then just print out teams I. So this for loop would print out teams 0, which is Phillies. Then it'll print teams 1, which is the Mets. And then it will print teams 2, which is the Yankees. So here's a case where we had three separate variables like we had before. We had three different variables, so we had to make up names for them, because every time you make up the name for a variable, you have to come up with some kind of meaningful name to it. We had three separate names. The only way to print them out was to print them out individually. But if we put them into an array, we can put them together like this, and then we can iterate through them. Okay. Okay, so now here's an interesting thing that comes up. When you buy a book, you go out to the bookstore and you buy a book, and let's say the book has 100 pages to it. The pages are typically numbered from 1 to 100, right? So if a book has n pages, the pages are numbered from 1 to n. If an array has n elements, shouldn't the elements be numbered 1 to n, just like in a book? And in most programming languages, but not all of them, most programming languages do not do this. They number them starting at 0 and going all the way up to n minus 1. So if you had a book with 100 pages in it, the pages would be numbered from 0 to 99. Now, couldn't the programming language simply add 1 to the pages if they wanted to? So the reason that they're doing this, the reason that computers do this, is they use the name of the array as a location very similar to a variable. very similar to a variable. So teams would point in your memory to the beginning of the array. And then if you wanted to read elements further on into the array, you would just add 0 or 1 or 2. So you go to teams, which is the very beginning of the array, add a 0 to it, and that's where the location for Phillies is. If you want location for the first element, you would add 1 to teams and jump over Phillies and then read Mets. So in computer storage, it might look something like this. Suppose we had an array of elements, and in this case, it looks like we have integers. So our array contains the numbers 15, 7, 11, 44, 93, and 20. As far as we're concerned, the array indexes are, and we're going to start, like I say, most languages, but not all languages, most languages index starting at 0. So we have 6 elements, 1, 2, 3, 4, 5, 6. Therefore, we index them from 0 to 5. So the index 0 points to the value of 15. The index 1 points to the value of 2. Sorry, the value of 7. Now suppose in your computer's memory, which has storage that is allocated at the time your program is running, suppose your computer said, all right, we have a chunk of memory starting at address 1100, and we're going to store your array at that location. And let's say, for example, there are 4 bytes for each of the numbers. So if your first element goes at memory location 1100, and it's 4 bytes long, the next one is going to be at address 1104. And then we put a 4 byte value there. And then at 1108, the next one, and 1112 is the next one, and 1116 is the next one, and so on. So if I want to find where is this element in storage, it's going to be at the beginning of my array, plus my index is number 3, times the size of each one of these. So where the location would be at this location plus 3 times the size of the element, and it would start right here. So the reason why most programming languages, C and C++, they always index using 0 to n minus 1 because of how the computation is done. It's the computation to find the location in memory where an element in an array is to take the beginning of the array, which is the array's name, and then add the index times the size of the storage to know how far into the array to go to find it. Like I say, we could easily just add a 1 to that. If I'm looking for the fourth element, I could just say, and take the index and add a 1 to it. And some programming languages do that. Okay, so, okay. Now, there's also the idea of multidimensional arrays. Suppose you wanted to have a deck of cards, and you wanted to have 13 different ranks and 4 different suits. So we could make a 2-dimensional array called cards, and it has, the row has 13 ranks to it, like A's, 2s, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. And then there's 4 different suits. And then we can start assigning the individual cards, like card 0, 0 could be the ace of spades, and card 0, 1 could be the ace of clubs, and card 0, 2 could be the ace of hearts, and card 0, 3, ace of diamonds. So now basically the 0 in the row column indicates the rank of the card, which 0 would be ace in this case. And then if we wanted to have 2s, it would be, 1, 0 is a 2 of spades, and 1, 0 is a 2 of clubs, and 1, 2 is a 2 of hearts, and 1, 3 is a 2 of diamonds, and then just keep doing that. So we would have a 2-dimensional array, 13 rows by 4 columns to have all 52 cards in the deck. And this is, of course, allowed. Now, in computer memory is always linear. So now we'd have to say, how would we store this? Would we store would we store the aces, followed by the 2s, followed by the 3s? Or would we store the spades all together, followed by the clubs, then followed by the diamonds and so on? Right? So the question is, how would we store this? And once again, different programming languages use a different approach. But the two different ways that they're done is they could be done in row major order, and they could also be done in column major order. So if you have a two-dimensional array, and you want to store values in row major order, you store the values across the first row. And then once the first row is finished, right after that, you start storing the second row. And when you get to the end of the second row, you then store the third row. You could also store the values in column major order. So this would be like in the last example, if we did the suits all together, put all the spades together. So we could go down the columns first, and then, so now the address is, the row number is changing. So we store this one first, this one second, this one third, this one fourth, this one fifth, this one sixth, this one seventh, this one eighth, this one ninth. Okay, so that's row major order and column major order. Okay, so for example, in the row major order example, suppose we had a two-dimensional array, and the green ones here are the first row, the blue ones are the second row, this is a magenta, and it's brownish orange over here. Okay, so if we wanted to store this two-dimensional array in computer memory, and computer memory is always linear, we could do it in row major order, and if we did it in row major order, the first four elements would be the first four elements of our two-dimensional array in storage. So here's what it looks like in our mind, and here's what it's going to look like in your computer memory. So if your programming language decided to store the two-dimensional array in row major order, it would store this two-dimensional array in our mind in this way. So now if I wanted to get to, let's say, this element, the magenta row, and the one to the third element in the third row, where is it located here? Well, what I'd have to do is I'd have to say, so if the address of this is 2, 2, right? So I'm using the numbering system where I start at 0, 0, 1, 2, 3, 0, 1, 2, 3. So if I'm looking for where is the square 2, 2, and we know it's going to be right there, right? So where's the square with the address of 2, 2? I would have to say how many complete rows are before me. So I have this entire complete row and this entire complete row. So that's that row and that row. They're before me, plus all the elements in this row that are before me have to show up before me here. So the way to calculate this, my offset really, how far into this linear array is the element I'm looking for. It's going to be the row number times the size of a row. So if I'm in row 2, meaning starting at 0, 0, 1, 2, if I'm in 2, that means there are actually 2 complete rows before me. So the row number times the size of a row, the row's length, that much stuff is before me. And then also, if I'm in column 2, when I'm starting at 0, that means there's 2 complete elements before me. So if I'm in row 2, 2 times the size of row, 2 times 4 is 8, plus the column number, and I'm column 2, so that would be 9, 10. So I'd be in position 10. Position 10 if I'm starting from the index of 0. So if this is 0, and I'm looking for this square, the 2, 2 square, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be the pointer right here. This is what I'd be looking for. So now here's the issue when you're using 2 or multi-dimensional arrays. When using one-dimensional arrays, the computer can very quickly, if you're going to access something, if you want to read data or write data to a location, it can calculate the location very quickly. It's the start of the array plus the index. That's if it's a one-dimensional array. Start of the array plus the index. If it's 2 or more dimensional array, this computation has to be done every time you read or write from the field. This could get time consuming. So you have to be judicious when you're deciding whether to use multiple arrays or not, because they can get time consuming. And also, just for completeness, we'll also talk about the column major way. So if we wanted to use column major assignment of a two-dimensional array to a linear field, then the columns, the green elements in this column would show up first in my storage, then these blue ones would show up, and then the magenta, and then the brownish ones would show up last. So how would I calculate that? Well, it'd be based on the address I'm looking for. Let's say, once again, I'm looking for the address 22. Well, let's make it a different one. Let's say 3.1, this box right here. I wanted to know where is 3.1, and my programming language decided to store my two-dimensional array in column major order. Then I would go through, if I'm in 3.1, I would do the offset, how far into the array I have to go to get to what I'm looking for, is going to be the column number times the column length. That's how many full columns are before me. And then, once I'm in my row, I add the row number. That's starting at 0. That's how many full squares are before me. Okay. So the language is going to decide how to store this. Now, as you can imagine, you can go into 3 and 4 dimensions too, depending on what your application is. Okay, so there is the concept of arrays of arrays. Some programming languages only allow one-dimensional arrays. They go from 0 to n, or 1 to 0 to n minus 1, or 1 to n. It's their choice. Some programming languages allow multiple dimension arrays, and some kick it up a notch further, and they allow arrays of arrays. This would allow the columns to be variable in size. This would make computing where the location of a field is very time consuming. Okay, so declaring arrays within different programming languages. Various programming languages. Some programming languages use the default, the first element uses the number 0. Like I said, it's convenient for doing math to have the start of your array be location 0, and in a one-dimensional array, the offset is added to the beginning of the array, and that tells you exactly where it is. You take the numbers of the offset, add it to the beginning of the array, and that tells you how far into the array it is. You could also add a 1 on top of that computation, so that way, like human beings who are used to things like a book, going from 1 to n instead of going from 0 to n minus 1, it's not that hard for the programming language to add a 1 to the number. So the default base index of 0 is used by programming languages like C, C++, Java, JavaScript, and Python. There are programming languages who find this, if you declare an array of size 0 to 10, and all the elements have to be numbered, if you declared an array of size 10, you have to number the elements from 0 to 9. Some programming languages find that confusing and decide to index them from 1 to 10. So for example, MATLAB, Fortran, Julia, and R use the index from 1 to n versus 0 to n minus 1. So just as an example, this is something that might be confusing, not so much to the end user, but to a computer programmer trying to debug something. So for example, when we were talking about the deck of cards, we said the first number indicates the rank of the card, right? We said that the rank would be the first number, and the suit would be the second number. So for example, if the first number is a 0, those are the aces. The different suits, spades, clubs, hearts, and diamonds, are these numbers changing, okay? What this would now mean is an ace ranks 0, and a 2 ranks a 1, has the rank of 1. So everything's off by 1. So if you're trying to debug a problem, you say, you know, 2 of clubs got printed out, I'm printing 1, 1. Shouldn't that be a 2? It could get confusing. So some programming languages do like to treat arrays, the indexes into arrays, exactly like pages in a book, starting at 1, ending at n. But most, probably more than half of programming languages, do not do that. So like I say, R and MATLAB, pretty popular programming languages that use matrices a lot. In fact, the MAT of MATLAB stands for matrix. They index from 1 to n as opposed to 0 to n minus 1. So again, now you have to be, you know, cognizant of what programming language you're using when you start indexing elements in an array. Okay, there's also the concept of bound checking. So suppose, for example, let me go back to here. Suppose I had an array called cards, and I have like 4 suits and different ranks, and then I decided I'm going to go to a field like, you know, row 14, card number, suit number 3. Well, there's only 13 rows of suits. So now I'm trying to access a field that is outside of my array. So based on, like, if I said cards, open bracket, 14, close bracket, open bracket, 3, the computer system would say the location I want is the beginning of the array plus 14 rows, but there's only 13 rows in a deck of cards, right? 13 ranks, 4 different suits. So it's 13 rows, 4 columns, adds up to 52 cards. But if I said I'm going to go look for the 54th card in the deck, there's only 52 cards in the deck, I could be running out to someplace past the end of my array and looking for storage. Writing to storage, reading from storage, that could be dangerous. So the question is, should we do bound checking? So in other words, if you take an array, do a computation of a location within the array, should the programming language, before you read or write from it, should it check first if the field you are looking for is actually in the array you're using to get to the storage? And there's pros and cons to doing that. The pro of doing that is to make sure you don't destroy some storage that's outside of your array. You think you're operating within your array. You coded up some for loop and the thing's running off the end of the array. You could destroy the storage that's part of your program that is needed to do a different computation. So that could be a problem. So for safety reasons, some programming languages have bounds checking. In other words, you use the array's name and index or a combination of index to calculate some offset into the array. Before you do anything with that array, you have the environment has to check, are you still inside the array? If you're not in the array, you get some error, you know, you're out of bounds, something like that. So what's the advantage to doing that? It blocks you from having programming errors. What's the disadvantage to doing that? Makes all your instructions where you're using the arrays take much more time, because you're going to calculate the location you're trying to read or write from. Before you go and take your action, the programming in the runtime environment has to check, is the action you're trying to do safe? And if so, it lets you do it. If not, it throws an exception and you get an error. So bounds checking will cause your program to slow down a lot. If you're accessing the array a lot, then every time you try to read from the array, this big computation is going to be done, and then a double check is going to be done. Are you before the beginning Are you after the beginning of the array but before the end of it? If so, allow the computation to be done. That could slow your program down a lot. So if you're a really good programmer who never goes outside of your array, you might want a programming language that doesn't do bounds checking. Otherwise you might. So C and C++ do not do bounds checking. Java introduced bounds checking. Most programming languages do bounds checking. But if speed means a lot to you and you know your program doesn't make any mistakes, you might like to have no bounds checking. Some programming languages allow multiple dimensions arrays or arrays of arrays. Some only allow you to have one-dimensional arrays like BASIC and RPG. Programming languages like C#, MATLAB, and PHP allow multi-dimensional arrays. And then the arrays of arrays, which is really where you can have an array of elements, and the elements are various arrays. They could have different sizes and types to them. Some programming languages allow that. So like JavaScript, Python, Java, they do that. Another issue that comes up is, what if you're using arrays? Do you have to know in advance how big the array is? So let's say, for example, there's 32 teams in Major League Baseball. So suppose you made an array of 32 teams for all the teams in baseball. And you have some software that's running fine, and all of a sudden, baseball decides to add 2 more teams. They want to add 2 more cities, make some more money. So they add 2 more teams to the league, and your array only goes up to 32. Can you just add 2 elements onto the end of the array, or is it going to say, sorry, when you originally declared the array, you said it was 32, we can't grow or shrink as needed? So can we dynamically change the size of an array? There's advantages and disadvantages to doing this. But there are languages who say yes to this, Java, JavaScript, Python. There are also languages that say no, like Go and PL1 and RPG. Do not let you adjust the size of the array once it's established. So what are the advantages and disadvantages of having the arrays grow and shrink dynamically? Well, okay, so suppose you had an array of 32 teams, and then baseball decides to add 2 more teams. So you'd like the array to go up to 34. Well, if you just append to the end of the array, if the array is of size 32, and then there's other storage for variables outside of the array that come right after your storage in memory, what the programming environment would have to do is create a brand new array that is bigger than the existing one, copy all the elements over to the new array, and then have some extra space for the thing you're trying to expand it to. So how much extra space should it, if the array needs to grow because you're trying to add one more thing, how much should it grow? Because we don't want to do this operation too often because it gets time consuming. You're trying to add one element to the array is full. So your runtime environment says timeout. I'm going to create a brand new array that's bigger, copy all the existing elements over to the new array, and then I have room to accommodate the new thing that you're adding. So the most common way programming languages do this is they double the size of the array. And so once they double the size of the array, then it can add the elements you're trying to add. So if you have a baseball array that has 32 elements and you're trying to add 2 more, unfortunately, if it's done dynamically, it'll grow to 64 teams, and you're only trying to add 2. But anyway, so can the arrays be double, and then also shrunk too, if need be. So the size could grow or shrink. Okay. So let's see. So when you're going to access an array, so we've been using pseudocode so far. If you're going to access an array, different programming languages do it different ways, but it's most common you would say the name of the array, open bracket, and then the index, the thing identifying the location, how far into the array. So if it's a multi-dimensional one, then it would be, index 1, comma, index 2. So if you had, rows and columns, you would just state the numbers. And then the calculation could be done how far into the linear storage you would go to access that field. C, C++, Go, Java, JavaScript, they all use this format. Name of the array, distance into the array. So, and if you're doing an array of arrays, the first element's array and the index into the array followed by the next array and how far into that array is. Scripting languages like Perl and PHP usually put a $sign in front of variables, whether they are single variables or arrays. And then other programming languages could use the open paren, close paren. But almost always this is the format that's used. So, okay. And then we kind of went over this a little bit earlier. If you wanted to iterate through an array, this is a lot better. This is one of the big advantages of using arrays. Like I said at the beginning, an array is a collection of variables that all share the same name, and they are just, the difference between them is the index number, or numbers if it's multiple dimension arrays, that could be used to identify which field it is. So if we had an array of 10 elements, and the elements are 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. There's two ways, depending on the programming language, you could look at this as you have 10 elements numbered 0 through 9, or it could be 10 elements numbered 1 to 10. How much room these take up will be multiplied by the index, and maybe you'll add a 1 or maybe you won't. And then if you want to, if you remember when we talked about loops, we can have a for loop, and the for loop can say for I equals 0, as long as I is less than or equal to the length of the array, so A is the name of the array, A is the name of the array, as long as I is less than the length minus 1, so I'm assuming I'm using a programming language like Java or C++, which uses the indexes from 0 to n minus 1 for the elements in the array. So I'm saying I is going to start at 0, as long as it's less than or equal to the length minus 1, I'm going to iterate, have I increment by 1, and then I could just print them all out. So I could print out every element. So like I say, I'm assuming the array is indexed from 0 to n minus 1. If you use a programming language that would index from 1 to n, not a problem. We would start I at 1, and we'd say as long as I is less than or equal to the length of A without the minus 1. Just unfortunately, with all the different programming languages, you have to make sure you know which language you're using and how it indexes the arrays.